move into chapter 8, which is a lot more focused on geometry, and not entirely the geometry that a lot of people had in high school, which was a lot of proof-based, two-column paragraph type of situation. This is just mostly going to focus on shapes, how to find area, volume, and how to deal with triangles and angles. So as an intro to angles, here I have two angles. If I'm going to be naming an angle or like mentioning it in a word problem, what I need to do is I always need to keep my vertex, which is kind of the part that isn't on either one of the arrows. It's almost the starting point of the angle. I need to put it in the center of how I name the angle. So the angle on the left should be titled ABC, or simply it could just be titled B. That can be a little bit confusing if we have a lot of angles kind of stemming from B. So ideally it would be better to write the entire angle out, but sometimes it's kind of obvious when there's only one angle what we're talking about. And the C and the A can be flipped. It'd be perfectly fine to name this angle CBA, just as long as that vertex is in the center. Same thing with this angle. I have angle KDR. D needs to be the center of the naming because it is the vertex, or I can just simply call the angle D. Some other things to be aware of. There are 360 degrees in the circle. That's going to be what we tend to use. There's a couple ways to represent angles, like degrees or radians. We're going to focus, at least in this section, on degrees. So if I travel all the way around the circle or turn all the way around, I have turned 360 degrees. Probably something that's a little bit less known is that if I want to break down the angles in almost something like a decimal, then I can deal with smaller units, specifically minutes, in which there are 60 minutes in 1 degree, and I can also break minutes down into seconds, and there's 60 seconds in 1 minute. So if I want to be really, really precise with my angles, and typically if we're just looking at a regular triangle, it's almost silly to write things out like this. But if I'm doing something like geolocations, which have, 360 is the distance around the globe, but if we're talking about a specific spot, we need to be super precise. We could write out an angle like this, and that would be the format you would use. You would use the degrees first, then the minutes, then the seconds. There's 3 types of angles. There's acute angles, which are less than 90 degrees. There's obtuse angles, which are not greater than 90 degrees. And then there's right angles that are equal to 90 degrees. And by equal, I mean the angle measurement, which is right next to that vertex. If I have 2 perpendicular lines, they're crossing each other. By definition, they cross each other at a 90-degree angle. So if you kind of see the classic X and Y axis, those are 2 lines that are perpendicular to each other. So all of those angles stemming out from them are 90 degrees. A straight angle, which just is a flat line, measures 180 degrees. So right here, I have 2 angles A and B. If I add them together, they form a straight line angle. And so we know that a straight line angle is 180 degrees. So this is going to be helpful when we're solving a lot of angle problems. If I have a flat angle, I know that the sum of each individual angles added up would get 180 degrees. So to kind of see that in practice in this question down at the bottom, I want to find the missing angles. This is not the easiest problem because we are having variables fly around, but it's certainly doable. So I notice I have a flat angle. If I look at 30 degrees and the angle right next to it, that x plus 3, that's a flat angle. So then I know that 30 plus x plus 3 is equal to 180, and then I just use my algebra to solve for x. I can combine 30 and 3 to get 33. Subtract 33 from both sides. I'm left with x is equal to 147 degrees. Now I'm going to take that result, and I see that my angle x plus 3 is a straight angle when it's added to y plus 20. And x is equal to 147, so I say 147 plus 3 plus my angle of y plus 20 is equal to 180. I combine all the like terms on the left side of my equation. I get 170. I subtract 170 from both sides, and I find that y is equal to 10. It should be 10 degrees. A little bit of a side note here. So if I have angles that are almost opposite each other, those are called vertical angles, and they're going to actually be equal to each other. So I could have saved myself a little bit of work on the right side when solving for y, because I know that y plus 20 and 30 degrees are vertical angles. I could set them equal to each other and solve in one step. Okay, some more angle properties, and this is a good slide because it has a lot of angle properties all in one place. So CF and DE are called interior angles, which makes sense because they're on the inside of that big line. And their measurements are equal, something I should mention before getting too deep into these properties. Those two arrows of the horizontal lines, those mean that those two lines are parallel. If I don't have two parallel lines, I actually can't have any of these properties. So again, the C and the F are inside the parallel lines, and so are the D and E, so those measurements are equal. I color-coded these. A and E, C and G, B and F, D and H are called corresponding angles, which kind of makes sense. They're all almost in the same spot, at least as it pertains to kind of that line that's coming through. And those measurements are going to be equal as well. So now we're going to kind of have, it's called an angle network. We're going to try and solve for all of these variables with very little information. And that's kind of the cool thing about angle properties is even if I have only one measurement like I have here, I can find honestly any angle that is represented here, but we're going to just focus on X, Y, Z, W. So for starters, the easiest angle is Z because that's a corresponding angle. So that's 110 degrees. Didn't really have to put a whole lot of thought or work into it, but I did have to remember my angle properties. Another very easy one, and that wasn't on the last slide, but we talked about it before. X is a vertical angle to 110. So then X is equal to 110. Y is a straight angle to 110, so Y plus 110 has to be 180. I subtract 110 from both sides, and I get Y is equal to 70 degrees. And now I'm kind of trying to solve for W, but there isn't really an immediate way to solve for W. And there are a couple strategies to find it, so you don't necessarily have to do what I'm about to do. But I'm going to put in, it's called a dummy variable, but I'm going to put in almost like this imaginary variable that wasn't there, but it's going to help me. And what I'm going to use that for is if I can find that variable, if I can find the value of t, I notice that's a corresponding angle to W. And since those would be corresponding, they'd be equal and I'd be done. Well, I can notice here that 110 and t are actually straight angles. So I know that 110 and t have to equal 180. And so 110 and t, if I subtract 110 from 180, I will get 70 degrees. Or additionally, it's a vertical angle to y, so I would also get 70 degrees. And then with that information, I know my W is equal to 70 degrees. And that's a really good strategy in almost, well, I don't want to say any geometry problem, but difficult geometry problems, if you're kind of getting stuck on what you're supposed to do on a certain step, it's a good idea to insert a variable and say, what if I find this, is it going to help me? Or maybe even do some drawing and say, okay, maybe if I find the distance of this line, it'll help me solve it.